Hello, math friends. Welcome to A Squared Math and Stuff. In this video, we are taking a look at some examples on the dividing out technique when we are calculating the limit of a function. So in this first example here, we have a rational function and the limit approaches -1. So the first thing we always want to do when we are working with limits is just let's see if we can plug in the limit that we're approaching and see if we get a value. So let's go ahead and just plug in -1 into this equation here. So we'll have -1 squared plus 6 times -1 plus 5 all over -1 plus 1. When you simplify the numerator, we end up getting a 0, and then the denominator is also 0. When we have 0 over 0, this is called the indeterminate form. Indeterminate form. And that's the 0 over 0, so 0 divided by 0. Anytime we end up getting a 0 over 0, that is an indicator that we want to go back to the original function and simplify it and cancel it in this case. So we are going to factor our numerator, and hopefully something between the numerator and the denominator simplify out. So next step would be to simplify, factor and simplify. So I'm going to go ahead and redo everything over on the right-hand side here. So let me just draw a line down, and I will rewrite the original equation that we are given. So I will rewrite limit as x approaches -1 of x squared plus 6x plus 5 all over x plus 1. And we want to factor the numerator. When we factor the numerator, we have the limit as x approaches -1 of x plus 1 times x plus 5, all divided by, scoot that over for you, all divided by the x plus 1. And we can see here that we have the x plus 1 in the numerator and x plus 1 in the denominator. So simplifying those down to 1, we end up then with just the limit as x approaches -1 of x plus 5. And notice that I'm continuously writing the limit as x approaches -1 every time I'm rewriting or simplifying the original equation. Now, when we go ahead and we start to plug in what number we are approaching, so in this case, we're plugging in -1, we no longer write that limit as x approaches that number. We completely drop that out and we just go ahead and substitute in. So anytime you're substituting in the value that we are approaching, you drop that limit, which means we now have -1 plus 5. So notice that I did not rewrite that limit. And when we work through this and simplify, we have -1 plus 5 gives us 4. And that's our final answer. So the limit of x squared plus 6x plus 5 all over x plus 1 as x approaches -1 is 4. Remember that when we are working with rational functions, anytime we simplify between the numerator and denominator, we have a whole. So we have a whole for this rational function at x equals -1. When we plug -1 back in, we find out that the whole is at -1, 4. Remember that the limit is the value of the y that we are approaching. So -1, 4 is where our whole is at, and we are approaching the y value of 4 for our limit. Let's take a look at another example. So the first thing we're going to do with this second example again is to plug in the value that we are approaching, that c value, and see what we get. So I'm going to plug in 1 everywhere there's an x in this equation, and we'll have 1 minus 1 all over 1 cubed minus 1 squared plus 1 minus 1, and we end up getting that 0 over 0 again. Again, this is the clue. It's the indeterminate form that we want to factor and simplify. So this time we're going to factor the denominator, and I'm going to factor by grouping. So let me go ahead and just factor that over here on the left first before I go ahead and start calculating the limit. If we take a look at x cubed minus x squared plus x minus 1, we can factor this by grouping. And then the x cubed minus x squared, I will take out an x squared, and I'm left with x minus 1 plus the x minus 1 because we can't factor anything out. So remember, there's an invisible 1 in front of the x minus 1. And what I need to do is both of these terms have the x minus 1 in common. So I'm factoring that out and bringing that to the front. And we have then x minus 1 times everything that we're left with. Well, we are left with the x squared plus 1. So that is what goes in our other set of parentheses. Because this is a plus sign here, we cannot factor any further. If it was a minus sign, we'd have our difference of squares and we want to factor just a little bit further, but we don't have that in this case. So our denominator factors to this. So when I work on finding my new limit, or not my new limit, but what my limit is, I'm going to actually factor or plug this into our denominator. So let's go ahead and do that. Let me draw a line down the middle here again so I can separate my work, and I will rewrite the limit as x approaches 1 of x minus 1 all over x cubed minus x squared plus x minus 1. And that equals the limit as x approaches 1. The numerator remains the same, and we are going to plug in what we factored into our denominator. So we have x minus 1 times x squared plus 1. So now we can see that we can simplify in our numerator and denominator. So let's get rid of the x minus 1. We then have the limit as x approaches 1, still writing that limit because we have not substituted in. We're left with a 1 in the numerator, and denominator is x squared plus 1. At this point, because it's as simple as I can get it, now I plug in my 1, so I drop the limit. I then have 1 over 1 squared plus 1, or 1/2. So our limit as x approaches 1 of x minus 1 all over x cubed minus x squared plus x minus 1 is equal to 1/2. And if you were to graph that, you would see that our graph approaches 1/2 from the left and the right hand side. So again, when you get that indeterminate form, the 0 over 0, you want to factor numerator denominator as much as possible, simplify out what you can, plug in what you're approaching, and you will find that limit. If you like what you saw, go ahead and hit that subscribe button, and I will be chatting with you later.